Hi, my name is Ubekha Josiah. I'm here to design and explain the thinking process of making a digital key lock. So our passcode is assigned to be our last 4 digits of our student ID. Mine is 0, 2, 5, and 1. So from that we can see that we are using only 4 switches to unlock this lock. 0, 2, 5, and 1. And all the other switches can be counted as 1 because we won't be using any of these. We can call this the end switch. Represents all the wrong switches. So our inputs will be 0, 1, 2, 5, and N. Now each switch can be sending out 2 data, which is zeros and ones, right? So now that we know each switch will be sending out 2 data, we can calculate the possibility that can happen with all the switches, which is 2 times 2 times 2 times 2 times 2 equals 32 cases. So now that we have these 32 cases, we can write out our state diagram. So my state diagram will start with state 1. If input 0 equals to 0, which means if the first input is incorrect, I want it to stay at state 1. And if it's correct, I want it to go to state 2. And if it's still correct, if I'm still pressing the 0 button, I want it to stay at state 2. And then if I take my hand off the switch, if all switches equals to 0, I want it to go to the next state. Now, I'm doing this because our clock wouldn't know how many times we press it, right? If we set our clock as 1 second and we press it for like 10 seconds, it will think we pressed it like 10 times. So when we do a case like this, we are telling the program that we are only pressing it 1 time here. And that when we take our hand off, the program will know that we are finished pressing. So we will do this for every state. The next input is 2. And then release. And input 5. Release. The last one, input 1 equals 1. Now for our 9th state, it is our LED state. So the LED will light up at this state. Now for our requirements, it says that we need to press anything to make the light turn off. Now if this is one case and we have 32 cases, that means all the other cases must be what? 31 cases to state 1. So any other cases that could happen will be sent to state 1. And then for our wrong switch detector, we want to send every wrong switch, every wrong case back to the first state. So these are the correct cases, right? Now we want to send all the wrong cases back to the first state. Now that all of these cases has like 2 cases coming out of them, right? That means 32 minus 2 is 30. That means all the other cases that would go to state 1 are 30 cases. So that will be our complete state diagram. So now that we have our state diagram, we can now write on to our state table. Considering from the first state, if input 0 equals to 0, it will stay at the same state. If input 0 equals to 1, it will go to state 2. At state 2, if input 0 equals to 1, it will stay at the same state. If all equals to 0, it will go to state 3. At state 3, if all equals to 0, it will stay at the same state. If input 2 equals to 1, it will go to state 4. At state 4, if input 2 equals to 1, it will stay at the same state. If all equals to 0, it will go to state 5. So at state 5, it will still be at state 5. If input 5 equals to 1, it will go to state 6. Now, the same thing at state 6. And then if all equals to 0, it will go to state 7. Same thing at state 7. If input 1 equals to 1, it will go to state 8. Same thing. If all equals to 0, it will go to state 9. And the same thing. Now, our output can be assigned to any state you want. So I will say I will put an LED light at state 9 to show if it's success or not. And then I'll put it at state 3, 5, and 7 just to check every correct switch. So now that we have this, we can now change it to our state assignment. Our state assignment is to assign all the names to a 4-bit binary code. So now I will change state 1 to 0, 0, 0, 0. And then state 2 to 0, 0, 0, 1. State 3 to 0, 0, 1, 0. State 4 to 0, 0, 1, 1. State 5 to 0, 1, 0, 0. State 6 to 0, 1, 0, 1. State 7 to 0, 1, 1, 0. State 8 to 0, 1, 1, 1. And state 9 to 1, 0, 0, 0. And done. So now that we have our state assignment, we can write out our flip-flop equation. Starting from our first bit, which will be considering only the ones because we're doing a min term. Here, 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 here. This will be our first bit. So if I assign my first flip-flop as Q1 here, that will be equal to this first term, which is the first state and input 0. And then the second state and input 0. The third state and input 2. The fourth state and input 2. The fifth state and input 5. The sixth state and input 5. The seventh state and input 1. The eighth state and input 1. Wait. So that will be 8 terms. Now going to the second flip-flop, which is, I will call it Q2. Which will be here, 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 here. Also 8 terms. So it will be equal to the third state and input 2. The fourth state and input 2. The seventh state and input 1. The eighth state and input 1. The second state and all equals 0. Which would be all bar. And then the third state and all bar. And then the sixth state and all bar. And the seventh state and all bar. There. Now the third bit, which I'll be calling Q3, will be here, 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 here. That is also 8. Starting from here, the seventh state and input 1. The eighth state and input 1. The fifth state and input 5. The sixth state and input 5. The fourth state and all bar. The fifth state and all bar. the sixth state and all bar. The seventh state and all bar. There. And the last bit will be Q4, which is only here and here, which is state 8 and all bar. And state 9 and all bar. So that will be our flip-flop equation. So for our test vector, I'll be testing pressing the right switches, pressing the wrong switches, pressing 2 switches at a time, pressing anything to go back to the first state. So let's start from a right switch, like 0. And then let's press something wrong, like 4 here. And then let's do it right again, like here, 0, and then 2. But for 2, we will be pressing it with another number, like 5 here. Now this will also take it back to the first state. And then now let's press the correct switches. 0, 2, 5, and 1 here. So after this, let's try to press anything to go back to the first state, like 9. This will take it back to the first state, and then we can start it all over. So here is our test vector. Let's try it out. This is our simulating window. So starting from 0, right? Here. 0 and then 4. 4 will be our end switch, which is here. And then 0, 2, and 5. 0, 2, and 5 at the same time. And then 0, 2, 5, 1. And then press anything to go back to the first state, which mine is 9, so it will be the end switch here. So now we can try to test it. So here, we started from the correct switch, right? So here it will go to the third state here. And then we pressed an end switch, which is the wrong switch. Now it came back to the first state. And then we press a correct switch again. Now it went to the third state again. But here we can see that we are pressing 2 and 5 at the same time. So it will go to the first state again. And then pressing 0, 2, 5, 1 here, it will go straight to the 9th state. So that means it is correct. And then pressing anything here to go back to the first state, which is here. Now this will go long till you press another number. So this is a success, which Thank you for watching, and if you have any comments, you can comment them below. Thank you.